Today we're going to work on 2.2, which deals with transformations of graphs. So I've written 3 equations up on the board. These are what we call parent functions. The first can be graphed using a parabola. And that parabola starts at 0, 0. And then the next point is over 1, up 1. Over 1, up 1. Whoa, I missed. What about the next points? Over 2, and what's 2 squared? Up 4. And then over 2, up 4. Okay. The square root of x is just a v that can be graphed over 1, up 1, and then over 2, up 2, over 3, up 3. And then the square root of x looks like this, and it's actually the same shape as the parabola, just turned on its side. So this right here, maybe it makes more sense to look at this side. If we were to turn that on its side, then it would look exactly the same as the square root of x. Okay? Now, how do we transform those? Well, what if I did y equals x squared plus 1? How is that going to affect the graph? It just moves it up 1. So it would have the same shape, and it would be up 1. All right, what about y equals the absolute value of x minus 2? Same shape, now it's down 2. Okay, what about y equals negative square root of x? What is that going to do? It's going to flip upside down. Good. So what that's saying is take all of the positive y values and turn them into negative y values. So this point here is 1, 1. And this point down here is 1, negative 1. And then 4, 2 turns into 4, negative 2. So a negative out front flips it upside down. Okay. What about y equals 3 times x squared? What is that going to do? Well, you take the y values and you times them by 3. Do you guys understand that? So normally we go over 1, up 1, but now we're going to go over 1, up 1, 2, 3. And over 1, up 1, 2, 3. And then we usually go over 2, up 4. But now we're going to go up 12 because it's 4 times 3. So it'd be way up here. What effect did that have? Well, it looks skinnier, right? But did we actually make a movement for skinnier? Not really. We made it taller. Yeah. So we refer to this as a vertical stretch. We made it 3 times as tall. Okay. What if I graphed y equals 1/2 times the square root of x? It's going to be a vertical shrink. So instead of over 1, up 1, it's going to be over 1, up 1/2. And 1/2 is a little bit hard to graph in ALEKS. You can do it, but 2 would make more sense. If I went over 2, how far up would I have to go? Up 1. So that graph is going to be half as tall. Does that make sense? Okay. What about, well, actually, let's not do that yet. What about y equals x minus 1 squared? Now notice, there's a difference here. One of them happens outside and one of them happens inside. Anything that happens inside the function has an effect on the x-axis. Anything that happens outside the function has an effect on the y-axis. So putting a negative outside flips the y's upside down. Adding or subtracting on the outside moves the graph up and down. Multiplying on the outside makes things taller or shorter. Okay? So, how do we affect the x's when we subtract 1? Not down. Yes, it's actually to the right, because the x-axis is right and left, but the trick is everything that happens to the x's is backwards from what you would expect. So x minus 1 actually moves it right 1. And then you would do over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4. It has the same shape as the original graph. It's just been shifted to the right 1. Okay? What about the absolute value of x plus 2? We're going to move it left 2. So left 2, and then it would be up 1, over 1, up 1, over 1, up 1. Okay. All right, what if I had y equals negative 2 times the square root of x minus 3 plus 1? Oh, yeah. We have to start on the inside. What does that do? Right 3. Okay. What does that do? Up 1. What does this do? Flips it upside down. And what does this do? Makes it twice as tall. So instead of over 1, down 1, it's going to be over 1, down 2. Over 1, down, oh, sorry, this is a square root graph. So we're up here, and we're flipped upside down. So it's going to be taller than the normal square root. So the normal square root would kind of look like that. Okay, does that make sense? All right. Okay. We start with the blue graph. We end with the red graph. What effect did we have? How did we move it? We moved it left 2 and down 3. So to write the equation, how do I represent left 2? Plus 2 inside. Oh, and the graph was already negative to begin with, right? This is the original graph. And then how do I go down 3? Good. Subtract 3 on the outside. Okay. All right. I start with absolute value of x, and I need to pull this graph to turn it into the absolute value of x minus 5 minus 2. So what effect does the minus 5 have? So we would move it. I don't know if it'll let me. Anyway, you just grab, oh. It won't let me grab it, but, oh, I guess I can just, so right 5 and down 2. I missed, but you guys get the idea. Anyway, I can't, it won't let me do it. Do you guys understand that? Okay. Same idea here. You grab the graph and move it down 5. And same idea here. You take the graph and you move it down 2. Okay? that takes care of 2.2.